Hello, and welcome to the last lab of CSE 4308. In this lab, we will be taking a brief look at some of the concepts of PLSQL, like anonymous blocks, if statements, and functions. So let's get started. Before actually moving on to the syntax of writing a PLSQL anonymous block, let's try to understand why these blocks are called anonymous. The main reason is that these program blocks do not have any names. For this reason, we call them anonymous. Unlike functions and procedures in PLSQL, anonymous program blocks are not stored in the Oracle server. So suppose you were to write a PLSQL anonymous block, execute it, and run it however many times you want, and you log out of your session. In the future, when you log back in, you will not be able to use that anonymous block that you wrote earlier because it was not saved in the Oracle server. To use that anonymous block again, you will have to write down the whole anonymous block from scratch, execute it, and use it again. All right. Now let's take a look at the syntax of an anonymous block. A regular PLSQL program block has three main sections: the declaration section, the execution section, and the exception section. Under the declaration section, we will be declaring all our variables. Under the execution section, we will be writing down the main logic of our program. And under the exception section, we will be handling exceptions. And as you can see, I have written down optional beside both the declaration section as well as the exception section. It is entirely possible to write down a PLSQL program block that does not require any additional variable declaration, right? So this declaration section is completely optional. Similarly, it is possible to write down a PLSQL program block without needing to actually handle any exception. So this exception handling is also optional. For this course, we will not be looking at exception handling in PLSQL, so this is something that we will not be worrying about too much. Our main points of focus will be this declaration section and the execution section. So a normal PLSQL program block will have three main keywords: declare, begin, and end. Under the declare keyword, we will be declaring our variables as well as cursors if we want to use any cursors. Under the begin keyword, we will be writing down the main business logic of our program. And finally, we will be ending our program with the end keyword. Now let's try to write some variables. The major syntax of writing down a variable is simply variable name followed by the data type of the variable. And if we want, we can specify whether we want our variable to be null or not null. And finally, if we want, we can initialize that variable with any value. So following this syntax, let's try and declare some variables. So first, we are declaring a variable called name, and it has the data type varchar. And as you can see, we have assigned it the value xyz. Note that in PLSQL, the assignment operator is not a simple equal sign. In PLSQL, the assignment operator is colon followed by an equal sign. Now, if we want, we can skip this assignment operator and instead use the default keyword. So then what this statement becomes is something like this: name varchar default xyz. So as you can see, we have simply replaced the assignment operator with the default keyword. Next, we declared two other variables, amount and portion. Both amount and portion are number type variables, where amount is set to not null, and portion is simply amount divided by 3. Now let's move on to our execution section, and in this section, suppose we simply want to print something. The way we can print something in PLSQL is by using the DBMS output.putLine procedure. Inside the parentheses of this procedure, we simply mention whatever we want to print. So in this case, we are trying to print this hard-coded string, welcome to the Thunderdome, followed by whatever name we have assigned in our variable. So in this case, we have assigned the value xyz to our variable name. So when we actually run this program, what we should get is welcome to the Thunderdome XYZ, right? Okay, so and as we can understand, this double bar operator is used to concatenate, to separate objects to print, right? Okay. Next, we will be printing another line which says your portion of the salary is, followed by the portion variable. Remember that this portion variable is basically amount divided by 3, right? So this will simply print 5,000 divided by 3, whatever value that is. Finally, we have our exception section. Now, as I stated earlier, exception handling is completely optional in this case, and we will not be worrying about it too much. But for the sake of discussion, suppose we want to handle division by 0 cases, right? So to handle that case, we can simply write something like this. Again, exception handling is not our major focus for this discussion, and so we will not be taking any deeper look into exception handling in PLSQL for now. All right? So finally, after writing all this down, we will end our program by using a forward slash. Now, before actually running this program in our SQL console, let's take a look at something. Let's take a look at this print statement. This print statement will basically try to print something in our SQL console, right? However, to indicate our SQL console that we want to write a program that will eventually try to print something in the console, we must write down a command first, and that command is set server output on. So this command needs to be written down after starting any session. So basically, whenever you log into your account in the Oracle server, if you intend to write down any program blocks that will try to print something on your SQL console, like the ones that we have written here, then you must remember to write this command down so that your console knows that you will be writing down programs that will try to print something on the console. If you do not write it down, if you do not execute this command before printing something, your program will fail to print things on your console. All right? Again, it is not necessary to write down this command each time you write down a program block. You only need to write down this command once each time you log in to your account. All right? Okay, now let's try to run this program block in our SQL console and see what we get. So as you can see, we have written down our program block in our SQL console, and now we will run it. So after running our SQL program block, PLSQL program block, you can see that our program is running correctly. We have printed the first line, welcome to the Thunderdome XYZ, and next we have printed your portion of the salary is 1666.667, which is basically the amount divided by 3 value in our portion variable, right? Okay, now let's try and perform some experiments. Let's replace this 3 by 0, that is amount divided by 0, and see what happens. So we have simply replaced 3 by 0, and now we will see whether our program runs or not. So after trying to run the program, this is what we get. You can see we get divisor is equal to 0 value. So this means that our exception handling is working. Now for further experiment, try this on your own. Try removing this exception handling and see what happens then. All right? Okay. Now imagine that you want to edit your PLSQL block, right? So while editing, it is actually quite irritating to rewrite this whole program block from scratch, right? So instead, what we can do is we can simply write the edit keyword in our SQL console and hit enter. Right after hitting enter, you will see that a notepad file will open, which basically contains the PLSQL program block that we are writing right now. In this notepad file, we can do any edit that we want. We can then save the notepad file, close it, and that edit or that change will automatically be reflected in our console. So let's change this amount divided by 0 back to amount divided by 3. And we save this file, we hit enter and we hit cross. And next, you can see that this is what we get. That change that we did in our notepad file has automatically been reflected in our SQL console. Now if we want, we can simply run this program again by using the /, and we can test whether our program is working or not. All right. Next, let's take a look at PL/SQL anchored declarations. To explain this topic, we will be taking the help of this table right here. The name of the table is boys. It has 3 columns, ID, name, and semester, and it also has some dummy data. Now, suppose that we want to declare a variable that will be able to store values from this name column into itself. Now, the problem is we do not know what the data type of this column is. Or another potential problem is that we do not know whether this name column will change its data type in the future or not. So what we can do instead is, when declaring a variable, instead of giving it any specific data type, we can bind it or we can anchor it to the data type of this name column so that we do not have to worry about the data type of this column anymore. So if we do that, even if the data type of this column changes in the future, or even if we do not know the data type of this column, we do not have to worry about it because that variable is anchored to this data type. All right. So as always, we have our keywords, declare, begin, and end. And under this declare keyword, we will be declaring our variable. The syntax for declaring anchored variables is very simple. We simply write variable name, then followed by table name.column name %type. In this case, table name is the name of the table. In this case, we have boys. Column name is the name of the column that we are referring to. And %type basically indicates that we are anchoring our variable to the data type of the column that we are referring to. All right. So let's declare some variables. So we have our first variable, var name, and we have anchored it to the data type of the name column of our boys table. Next, we have var semester variable, and we are anchoring it to the data type of the semester column of our boys table. Now let's perform some operations using these 2 variables that we have created. Imagine that we want to store the values of name and semester of that student whose ID is 2. Basically, we want to store Saidul and 8 in our variables var name and var semester. The way we can do this is by simply writing an SQL statement. So let's write down that SQL statement, which will eventually copy the values Saidul and 8, where ID is equal to 2, into our var name and var semester variables. So after writing down this command, what will happen is our var name variable will have the name Saidul, and our var semester variable will have the value 8. So let's try and print those 2 values using our DBMS _output.putLine statements. And finally, we can end our PL/SQL program block using the /, right? Okay, now let's try to run this program in our SQL console and see what happens. So we have written down our PL/SQL program block in the SQL console. Next, we run it, and as you can see, we do indeed get name of the student Saidul and semester of the student 8. So now we understand how we can write or how we can declare anchored variables in our PL/SQL program blocks. Our next topic is if statements in PLSQL. So the general syntax of writing an if statement or if conditions in PLSQL is very simple. You have your if keyword, then you have your condition, then you use the then keyword, and then you write your statement. And you follow the same procedure for else if and else conditions. What you need to remember is that you need to end at the end of all of your if conditions, you need to end the conditions by using the end if keywords. So after you're done writing all your conditions and your statements, you need to end that if conditional block by using the end if keywords. All right. Now that we know the syntax for writing if statements, let's actually use the syntax to implement an example. To understand the implementation of the if statements, we will take the help of another table called boys marks. It has 3 columns, ID, name, and marks, and as you can see, we have some dummy data as well. Our objective is to categorize students according to their marks. So if someone got anything greater than 79, then his grade is A. If someone got anything greater than 69 but less than 80, then his grade will be B. And if someone does not fall under any of these 2 conditions, then his grade will be C. So for now, what we want to do is we want to extract the name and marks of the student with ID 2 and categorize them according to the conditions that I just stated. So let's first declare some variables. We have a variable called var_name, which has the same data type as the name column of the boys marks table. Next, we have another variable called var_marks, and it has the same data type as the marks column of our table. Finally, we declare a third variable called grade, and this variable will basically store the type of grade that we will get from the categorization of marks of the student. Now, let's write this SQL command to extract the name and marks of the student ID 2 and store those values into our var_name and var_marks variables. Next, what we will do is we will write some if conditions to categorize those marks. So if the marks is greater than 79, the grade value will be A. If the marks value is greater than 69 but less than 80, then the grade value will be B. And if none of these conditions are satisfied, then the grade value will be C. So we have successfully written our if statements, but now we have to end our if statements, so we simply write end if. Finally, we will be writing 2 more statements that will basically print the values of the name and the grade of the student. So from our table, we can see that since the marks of the student with student ID 2 is 85, he falls under the first category, so his grade should be A. Let's run this program in our SQL console and see if that is actually what we get. So we wrote down our program block in the SQL console, and now after running it, as you can see, we do indeed get the name of the student as Seidel and grade of the student as A. So we understand that our if conditions are working properly, and now we have a basic idea of how we can implement if statements. Our final topic for the day is PLSQL functions. PLSQL functions are named blocks or non-anonymous blocks in PLSQL. So unlike anonymous blocks, functions or procedures in PLSQL are saved in the Oracle server. So even if you were to log out of your session, if you log back in the future, you will still be able to use that function. Now let's take a look at the general syntax of writing a PLSQL function. You have your create or replace function keyword, followed by the name of the function that you want to use. So you can use any name that you want, but just remember to use a meaningful name. Within the parentheses, you will specify your parameter list as well as the data type of those respective parameters. So it will be your variable name followed by the data type of that variable. Next, you have your return type keywords. So in this case, we are basically specifying the data type of the value that we will be returning from our function. Finally, we have our is keyword, and then we start writing the body of our function. First, we have our declaration section, And in this case, we will declare any variables that we want. And if we do not want to use any variables, that is, if we do not want to use any additional variables in our function, we do not have to declare any variables in our declaration section. Next, we have the begin keyword. And after writing the begin keyword, we will write the main logic of our function. So it is basically the execution section of our function. And after that, we have the option to write some exception handling code as well. Again, that is completely optional. Finally, we end our function with the end keyword and save it by using the / operator. Now, compare this function general syntax with the syntax of writing an anonymous block. The main difference, as you can see, is that there is no declare keyword in the function writing. So we do not have to use the declare keyword in the main body of the function. The declare keyword is only reserved for anonymous blocks. Okay, so let's use this syntax to write some PLSQL functions. To understand the implementation of PLSQL functions, we will be taking a look at a more elaborate example. Suppose we have two tables, orders and order items. The orders table has 3 columns, order ID, client ID, and order date, and order items table has 4 columns, order ID, name, quantity, and price per unit. Our objective is to write a function that takes a date as parameter and returns the total money earned in sales on that date. So for example, if our function takes 22nd June as input, then it should return the total amount of money earned in sales on 22nd June. So if we look at our tables, we can see that order ID 1 has been accomplished on 22nd June. And from the order items table, we can see that the order with order ID 1 has only bananas, and 6 units of bananas have been sold, and the price per unit of bananas is 9. So our value here should be 6 times 9, which is 54. So you get the general idea of how this function should work. Now let's write this function. We have named our function getTotalSales, and inside our parentheses we have mentioned that our parameter list will only contain one variable, and the data type of this variable will be date. And remember, in this case, we have named our variable as inDate. Next, we have our return clause, which states that our return type of the function will be number. So since our function will be returning the value of total amount of money earned in sales, we can understand that the return type is obviously going to be a number type. Next, we write our function body, and in our declaration section, we specifically declare another variable called total sales, and we assign it the value 0. This is the variable that we will be returning from our function. This variable will basically store the total amount of money earned in sales on the date that has been mentioned in the function parameter. Now we have our main function body, and in this case, we will be writing an SQL statement that will give us the total sales or total money earned in sales on that date. So we can understand from our objective that we have to use the sum aggregate function here as well. So we write select sum quantity times price per unit from our orders, item table, and we store that value into our total sales variable. Take a look at the condition that we have used. We have specified that the order ID column has to be the same for both the tables, and the order date has to be the same as the date that has been mentioned in our function parameter. Next, what we have to do is we have to return the total sales, right? So we simply write return and then the variable name. So basically, we are returning the total amount of money earned in sales on that date. Now we can end our function and we can save it. Now the question is, how exactly do we call this function? Well, there are 2 common ways of calling a function. We can use an anonymous block to call this function, or we can also use a simple SQL statement. If we were to use an anonymous block, we can do something as simple as this. We can write a print statement, and inside the print statement, we call the function, and we pass any date, and in this case, we have passed 15th of June as the date. If we want to use an SQL statement, we can simply write select get total sales, and in the parentheses, we specify the date from dual. So in this example, as you can see, we have stated 15th of July as our input date. So let's take a look at our tables and see what the answer should be. In our orders table, we can see that 2 orders have been made on that date, which is order ID 2 and order ID 3. Now, if we look at our order items table, we can see that there are these 3 rows that correspond to the order IDs 2 and order ID 3. And according to this table, 10 units of apples have been sold, 15 units of oranges have been sold, and 50 units of coffee have been sold. So the total value here should be 10 times 5.5 plus 15 times 5 plus 50 times 6.5, which is 455. Now let's see if this is exactly the value that we get in our SQL console whenever we write and execute this function. So as you can see, we have written our function in our SQL console and saved it. Next, we will be calling this function by using an anonymous block, as we have shown earlier. And after running it, as you can see, we do indeed get 455. So we can understand that our function is actually working perfectly. So now we understand how functions work in PLSQL. There is another thing in PLSQL called procedure. They are basically the same as function. The only difference is it is not a necessity to explicitly specify any return type in procedures. So the procedure declaration will not have this return number or return data type keywords. So that marks the end of our lecture on CSE 4308. It was a fun and learning experience for me trying to teach you guys some of the things that I know. And despite the many flaws that the lectures had, I do honestly hope that I was able to teach you guys some of the things related to database that will eventually help you develop your own database related projects. So yeah, take care and I will see you around.